This presentation is an overview of the design of the Survival Master multiplayer role-playing game. The presentation has about a dozen slides or so. This is a synopsis of the larger design package. And one of the things that I'm not going to cover in this presentation is the underlying curriculum framework. So we invite you to please go to gamingtolearn.org, and in the Survival Master menu under Curriculum, you'll be able to pull up the curriculum framework, the key ideas, the analog curriculum for the physical modeling, the teacher's guide. So please go there and visit that, and that will explain the curriculum. And the curriculum framework, of course, is the same for the game as it is for the traditional analog activities that happen in the classroom. So in this presentation, I want to take you through the game sequences, the gameplay, how we have highlighted player choice, how the game is situated in terms of its environment, and then take a look at the design of the session in the multiplayer and what the players do in terms of how they execute setting up their avatar and how a team session is managed, and then exactly what the learning activities are that they go through in the game. So the sequences of the entire Survival Master game is comprised of a single player mode where the knowledge and skills builder activities are done single player, so everyone can work at their own pace. And then players are formed into four-person teams where they then participate in a role-playing game, multiplayer, and do the shelter design challenge where they have to work together to engineer a shelter that will allow them to survive the night in the coming storm. So the first sequence is they need to log in and they do their initial player setup. Then they go to an orientation level where they learn to use the game controls and get a chance to explore the space, exterior space of where Survival Master is situated in Alaska in the mountains, not far from Fairbanks. And then they go through, in order, the knowledge and skills builders. So the first one is volume and surface area, which is a math diagnostic to make sure that the students have the skill to be able to calculate volume and surface area of the primitives that they're going to be, the geometries that they're going to be working with in the game. Heat flow, which is new instruction, and they're going to learn about the heat flow formula and where each of the variables in the formula is derived from and do activities that pertain to those. Then the R value, KSP3, they're going to learn about insulators and thermal conductivity as it's applied to R value, and then they end with the structural activity where they learn about strength of materials and bracing, and gives them an opportunity to do some experimenting there. In the design of these sequences, the KSP1 as a game design is a puzzle challenge game. So it's a puzzle matching game. KSP2 is designed to be a platformer. KSP3 is an action race game, and KSP4 is a construction game. And then this all culminates when they log into the multiplayer. They reconfigure, so they reconfigure their avatar. They select the role that they're going to play in the game. And then they join their teammates in the game world, and they have a task that they have to work together, collaborate on. They need to go out and gather materials in the environment so that they can make a shelter. Then they need to plan what the shelter is going to be like, and that's an engineering type of planning. And then they're going to construct, test the shelter, and as needed then replay. They can replay as a team in the multiplayer, and at any time they can come back and replay any of the KSBs. So at any time they can come back in the single player mode and replay those as much as they like. The key commodities for the Survival Master player are energy and achievements. So you begin in the first level, KSB1, and from there forward your avatar is trying to collect energy. So you need energy. Might be called health in an entertainment game. And you also are collecting achievements, and the achievements are something that you can come back and earn if you didn't get a chance to earn them the first time around, and this is very similar to achievement design in entertainment games. So those are the two prime motivators, and that's what's going to be driving the player through the game. So the multiplayer gameplay is for a team challenge. The team has to work together, and they have to build a shelter, and they have to survive. So the end goal is the team survives, and along the way the players are trying to accumulate as much individual energy and achievements as they can, which also comprises a composite team score. So the players have avatar configuration that they are in charge of, and they can elect a role. By the way, they can change roles if they like in the middle of the game. They're earning achievements, and then it's their primary attraction is managing their energy level. The team membership is set up by the teachers, and then they're working together to plan a shelter. So they have to plan the shape, and then they have to plan the frame. They have to gather the materials so that they can make the frame and cover it with sheathing. And then they're going to construct it, they're going to apply the materials, and then they're going to test it. They're going to test it for heat flow, and then wind load and snow load. So the built-in player choice is, firstly, they're encouraged to go back and replay the KSPs as often as they like, so that they can accumulate additional energy and also earn achievements that they may not have earned the first time around. The class has a high score table, both for players and for teams, and then the game is also designed so that the gameplay evidence is available in the XML database, so that the reporting of that can be used for assessment. So the actual game performance could be used for grading. In the character setup, they're going to configure their avatar, they're going to elect their role, and then they're going to use character setup to make sure, or to manage, their energy and achievements. So that's where they go in their avatar setup to compare their achievements to achievements available and to see what their energy use and award has been in each level. So the roles are Lynx, Marmot, Falcon, and Bear. And these roles are typified, targeting Bartle's players' suits. So the Lynx could be a killer player type, and the Lynx has double energy. So the Lynx can sprint and gets more energy awarded, and its energy refills more quickly. The Marmot is a socializer, communicator, so the Marmot can see the energy levels of all the other players, and it's going to be important as the team is collaborating in the space to try to distribute the workload so that no unfair burden is placed upon any one player to burn up their energy to go find things or carry things or build things. So the Marmot is the only one that can see everyone's energy levels in their interface. The Falcon has the advantage of being able to see materials and statistics on materials from much farther away, so they don't have to get as close to them and spend as much time and energy navigating the environment to get to things, to investigate them and see if it's something that the team wants. And then the Bear is an achiever, and the Bear has more strength, and the Bear can carry more weight per energy unit expended. So the game is situated in the mountains in Alaska in the winter, not too far from Fairbanks. So this is a map of the location of the game environment. Of course, this is not a real map of Alaska. This is our rendition of what this area would be, but it's drawn from actual topography not too far away. And how the map is set up is, as you can see in these yellow labels, each of the KSBs has their own dedicated area. KSB 2 and KSB 1 are located in underground. They're in a cave, so in an underground former mining facility. So those are entrances to the underground. And then KSB 4 is in the far upper northwestern corner in a box canyon. By the way, that happens to be where they are when the earthquake strikes and strands them. And then there's a briefing area and supply hut and laser range and helipad. And the KSB-3 race takes place in the far upper northeastern corner. There you can see, and then there's some residential huts. So what happens is, in this earthquake, as you would read in the design challenge document, the snow avalanches buries all of this stuff. So they're trapped in the box canyon. They have lots of fragments of materials that have been left on the surface as a result of these avalanches, but they have to scrounge from those. They don't have access to any buildings or any construction. So the architecture of the game is built around the team session. So the teams are determined by the teacher using a console to set them up, and the teacher can reconfigure teams as needed. So teams might be changed from day to day, depending upon the needs of the teacher. And students can be absent, and the team can continue, and then the student can rejoin the team, and the player can even leave in the middle of a session and rejoin a session and still participate. So the configuration, we have it organized by color, and the teacher opens up the session from a list and starts it, and then the players, when they log in, they're already populated into their game, so it's the only game that they can join, and then they join their session, and the first thing they do is they go into their setup and make any changes they want to their avatar, and then they're spawned into the game. So then what the players do in each session is the sessions are defined by activities that require a vote. So then they vote as a team to, yes, we accept this shape as our shape design, or yes, we accept this frame, or yes, we accept this material. So then they vote on that, and then that's a saving point and finishes a session. And the teacher also has complete control over start and save. So the teacher can just have the students all leave at the end of the class period, and then the teacher can just shut down all the sessions and save them. So it doesn't require any active management by the team. However, the team can elect to have a vote to save where they are. So they may have decided, we're not sure about this shape yet, so we don't want to commit. We know it's going to be a choice between two of these four, so we're going to reject two of them. We're going to keep two. Let's save here, and then when we come back tomorrow, we're going to start at this point. So the game is a LAN multiplayer, and it's up to 4 people in a team. It's not a technical requirement. We could have many more in a team, but we're designing it to be played by teams of 4. And it could be anywhere in between, teams from 1 to 4, depending upon who's in class on that particular day from their team. And the teacher uses a flash console, and that's how they negotiate with the database that controls the game, and then all of the data is being handled by XML. So our thinking is that this architecture is going to give us the greatest degree of flexibility so that the game can have some shelf life, so that as tools change and technologies change, when this game needs to be repurposed and perhaps used with a different development software to continue developing, this XML-based architecture is going to be portable enough that it will be very easy for us to take this and move it into another environment post-project. So after we get past year 5 and into year 8 or year 10 or whatever. Also, it would allow us to easily share this with a group that might want to take the architecture and use it with their tool set. So they might be using a different application than we are, and this would be something that would be pretty easy for them to onboard. So the console for the teacher allows the teacher to first of all populate the class into the system. So you need to add a student, or you might need to reconfigure a student, and then you want to see as the teacher what's going on with the student profile, so you can do that at any time. The teacher needs to work with teams, so you need to configure a new team, and then you will probably need to reconfigure teams, and then you want to see what's going on with the team. And then the teacher can add new sessions and begin sessions, reconfigure a session that has already started, end a session, and then the teacher also has the ability to view the chat log. So whatever the chat strings were that the students entered while they were playing the game. Those are available for the teacher to read in a report format. And then there's a number of reports that would be of use for the teacher, being able to view status reports from the team, view a profile dump of where each player is, what their profile looks like, status reports from the game as a whole, and then also have the ability to create new reports. So that's a module yet to be defined, but we can certainly see the need for teachers being able to create their own custom reports that would be useful for their grading or their particular curriculum use in the classroom. And then this is intended to be a console that the teacher uses real time while the game is being played in their classroom. So we have a button here to open the teacher's guide, which is a PDF document that they may want to read. They can open the high score table, so they might want to project that for the class as a whole to see. They can open up the game lesson notes, so they can look at the document that's providing background on the curriculum design, and then if they need to, they can quickly open up the graphic that shows all of the game controls, so they might need to highlight something that the students might need some help with in terms of voting or navigating around the space, or perhaps working with their avatar setup. Speaking of which, player setup. So the player is in charge or can change their gender, their body type, their clothing, their hair, and accessories. And then they can change their avatar at any time. So if they want to, they can change any of those configurations anytime they want. They can also change their role anytime that they want. They just need to come back to player setup and change their role. Some things don't change. Achievements earned, those don't ever change. So as they're earned, those goes into the profile and those stay constant. And then those are accumulating. Same thing for energy. So a player is going to have energy as a ongoing living commodity in their profile. So they'll be consuming energy and getting energy awarded, and then they'll be in charge of managing that. And they'll be able to come back into player setup and see this is where I've used energy, or this is where I've earned energy. There's no maximum energy level, so the player can continue to earn more and more energy. When a player has depleted their energy level to the base, then they can still move, so no one is disabled and you don't die in Survival Master, but they can't carry and they can't build. So they would be able to move, they'd be able to help, they'd be able to vote and contribute, but they wouldn't be able to carry or build. And if they, in the worst case, need to be able to carry or build, then they would just have to rest, and then they would slowly regenerate. However, that would get increasingly more difficult, because as the outdoor temperature drops in the game, then that consumes more energy. So at a certain point, there's a point where the player is not going to be able to rest to regen, because they're going to be expending more energy than they're regenerating because it's so cold outside. So then this is the design of the interface for player setup. And over on the right, the three little circles at the top show the other three players in their team and what their configurations are in terms of their player and role. And then the panel here in gray with the three buttons is where they make these changes that they're going to elect to their character. We have our standard global interface buttons in the lower right, and then we have chat enabled so that the team can chat while they're not in game, but they're in this player setup, so that they can talk about here's things that we're thinking about as we're changing their role. So they might decide, let's all try this role, or let's make sure that each of us has a different role, or whatever it is that they need to communicate. And then this long thin gray segment on the left is feedback. So if I'm making a change to my avatar, I see my avatar in this feedback, and when I change my clothes, change my gender, change my body, I see that feedback in that window. So here's an example of the image that they'll see in the actual interface, and this is the actual interface of the game. And it will show the current energy level, it will show the player's name, it will show the player's avatar that they've selected, and these are collapsible. So many things can be minimized in the interface, so you can minimize these. You can also minimize the mini-map in the upper right-hand corner, and On the left-hand side is their energy meter and their own avatar setup. That can't ever be minimized. And the chat is in the lower left-hand corner, and that, of course, can also be minimized. So the first thing that they're probably going to do, they don't have to, they could plan shape first, but probably they're going to go out and gather materials. And that's one of the bigger challenges, cooperative challenges, spatial challenges in the game, because it's a very large space. And items are randomly strewn around, so they need to go find out what's out there. When they get near a material, then there is a small image, a billboard that turns toward them, and it tells the player this is what it is. Here's the type. Here's how many of these there are. This is how much this stack weighs, and you have to pick up the whole thing or nothing at all. And the K value. So then players can only carry a certain amount of weight, depending upon their role. So they can't just go around and pick up everything and then take it back to the depot point where they're going to build their shelter and drop it off. Players can earn individual energy awards for any given material by calculating the R value. So when they are inspecting the billboard, if the R value for that particular item has not yet been calculated, then they can calculate that with their calculator and earn the extra energy boost for having input that R value. And then our R value is evident in the billboard if someone else inspects it, so it can only be earned once. When the materials are collected, the player brings them back to the place where they're going to build their shelter and drops them off. It's a depot. And when they drop off those materials belong to the team, not to the players. So a player could play in one team for 2 days and collect a bunch of materials and then be assigned to a different team by the teacher, maybe to help in the third day. And the materials that would be available when they joined the new team would have been those that the new team had earned. There's no profile bonus for the individual player for earning materials either. And then once materials are in the inventory, they are reusable. So if I go out and collect enough styrofoam pieces to sheathe my shelter, and then I build my shelter and decide that it's got to be changed because it doesn't work, then I still have those styrofoam pieces available to me. They're not consumed. In planning the shape and the frame, the players have 4 wireframes that appear, and there's a hemisphere, a cube, a square-based pyramid, and a cylinder. They're required to reject 3 of the shapes, and they have to annotate why they're rejecting those. So what they're going to do is they're going to look at the footprint of the shape, and they have some body proxy models that they're going to use to evaluate the size, and then they're going to calculate, well, here's the volume of this that I have, and because of these dimensions and the formulas I can calculate the surface area, and now I can calculate the heat loss that will happen because of the surface area. So I mean, I can know more surface area is going to be more heat loss, so then they can decide, okay, we're going to go with this one shape and we're going to reject these others, and they have to vote on that. Once they choose a shape, then they're going to optimize the shape by changing the subdivisions. So that's going to determine the framing. And once they have determined their framing, then they're going to decide bracing. So will they have bracing? Will they have only horizontal bracing? Will they have horizontal and cross bracing? Will they have only cross bracing? The more bracing they use requires more framing material, and the more framing material and construction required, that burns more energy. So they are not encouraged to over-engineer the frame because of the energy cost. So here's an example from the game of moving the primitives into place and then using the proxies to make sure that the primitive adjustment is going to accommodate the size of the 4 team members. And once they determine that they have the shapes that are sufficient and not any larger than they need to be, then they're going to be able to make those choices, and then they're going to reject 3, and then they're going to work on their framing. So then they build, and they're going to apply the materials, dragging and dropping the materials onto the shelter, and the materials aren't consumed so they can reuse them. When they're ready, they're going to test the shelter. They're going to vote, yes, we're going to test it, and the test is going to give them a yes-no report for 3 factors, and they have to pass all 3. Does the test meet the design requirements for heat flow? Does the test meet the design requirements for the wind load? And does the test meet the design requirements for snow load? So then if any of those fail, then they need to iterate. They need to make changes, whatever those changes are going to be. And each successful test, then the players earn energy bonus points. So the amount of energy bonus points that you can earn is decremented by successive failures. So if you have to rebuild and retest 8 times, then your energy bonus is very minimal compared to if you were spot on and designed a shelter that passed the requirements the first time around, where you would get the maximum bonus. Lastly, we have reporting for the game. So we have a high score table that's available, not required, so that may or may not be something teachers want to use in the class. We have a team high score table. We have teacher reports for classroom management that are going to be available in the console, and then the teacher can use game activity for assessment. Of course, we get our project reports that we're using for our research assessment, and that's a copy and paste on the bottom of the extra score tables. So then reporting is the final feature that we're leveraging from our multiplayer RPG system. So again, we encourage you to explore gamingtolearn.org and read about the curriculum framework. And there's a movie on the front page in the lower left-hand corner that explains the field test opportunity that we're interested in 8th grade technology education teachers that might be interested in joining us. So then you can watch that and learn more about that. There are also a number of other items to explore in the gamingtolearn.org interface, a link to our Flickr, our YouTube channel, the development blog. So we encourage you to please take some time and explore that.